This is Mrs. Butcher, and this video is about solving rational inequalities. And for this section, we're just going to do this using your graphing calculator, so make sure you have that. And I want you to use a graph to solve 4x plus 3 over x minus 2 is less than 0. So when you put that in your calculator, it's going to look like this. We'll have a vertical asymptote at x equals 2. We'll have a horizontal asymptote at y equals 4. And the graph is going to look something like this. And that's crooked, but that's okay. So now what you want to do is you want to look at this part. So we've got the graph of 4x plus 3 over x minus 2. We want to know, where is it less than 0? Less than 0 is below the y-axis. So that would be all of this part down here. X-axis, sorry, all of this part down here. That means this is the part of the graph that we care about. Just this part right here. And so if you were to transfer that to your x-axis, you'd have everything from here to here, and then it stops at your asymptote, and it doesn't actually touch your asymptote. So these darkened areas here, I'm going to do it in pink, from here to here, are the only x values that we have that are less than 0, where the graph is less than 0. So what we need to do is do second calc intersect to get that x value, and you would get an x of negative 3/4. And then this is all less than, so it's less than x. And then it stops on the right at our asymptote at 2, so less than 2. Only the x's between negative 3/4 and 2. Okay, here's another inequality. Negative 6 over x minus 1 is greater than 0. So the same thing, I want you to put it in your calculator and graph it. It's going to look something like this. You've got a vertical asymptote at x equals 1, a horizontal asymptote at y equals 0, and then you have the curves, the hyperbola, like this. So now we care about, where is it greater than 0? This time, where is it above the x-axis? And so the part of the graph that matches up with that is all of this branch here. So it actually continues on, and because it never crosses the asymptote, it's always above the x-axis. So we know this is negative infinity, and then it stops at this kind of this force field at our asymptote. So it's all the x values that are to the left, I'm going to color it in, to the left of the asymptote. And remember, left is less than, and that asymptote is at 1. X is less than 1. Okay, now for this example, I have x plus 1 over x minus 3, and then I have less than or equal to 3. So in your calculator, you're going to put the rational function in y1, and you're just going to put 3 in y2. And so when you graph it, it will look like this. Here's the graph of the rational function. We have a vertical asymptote at x equals 3. We have a horizontal asymptote at y equals 1 with our hyperbola here. And then when we graph y equals 3, that's going to go through right here. And now I want to know, where is the curvy graph, the rational graph, less than, so under the line, 3. So that's everything under here. So if I were to shade the part of the graph that goes with it, all of this and all of this, then that corresponds to all x values here, all the way up to the asymptote, but not including the asymptote. So that's going to be x is less than 3. But it also includes these x values from here on out. And that goes on to infinity. So we put and x is greater than, and this one's going to have an equal because our problem had an equal, and it does actually touch here. And so we need to find this intersection. Just use second calc intersection to find that, and you'll get that x is 5. So x is greater than or equal to 5. And that's it. I'm just doing 3 examples for this. It's the same process we've been using for all our other functions with inequalities. Just use your calculator and look at it. All right, thanks guys, and I'll see you tomorrow.